All right. So for today, we're going to cover Chapter 1, plus we're going to cover some of these note topics. Now, we all get it, at least most of you got it installed. I think 17 out of 20 of you did the homework assignment already. Pretty easy. Worked fine on your Mac over there? Yes? She got, what's her name? What's your name? Caitlin. Worked fine on your Mac, no problem? You're good? Everybody else, who else has a Mac in here? Wow, quite a few of you. Good to go on your Macs? Now, I know someone asked the question, you can bring your laptops here and use them if you like. Just put them on the desk or move the other machine forward or whatever, because that's totally fine with me as well. Let's talk about a few things. Okay, let me bring our textbook up here. If you want, you can actually just make a link to the textbook on your desktop. I'll show you how to do that if you've never done it. Say you're on your desktop here. If you right click and say new shortcut, you can actually paste in the shortcut for the book and call it book. And now you have a shortcut. Whenever you click on it, boom, goes straight into the textbook, no problem. Okay? So that way you don't have to keep searching for it. And if you put it on your desktop, it does stay with your profile, so next class period will be there. It'll just save you from having to hunt the darn thing down. All right, so we're going to cover Chapter 1, but we're also going to talk about a few slides here. Now, these slides are actually made by Jeff Thompson. I'm actually using a lot of his materials. And I'll tell you, we got into a big argument about the textbook. The bookstore's not happy. Those of you who bought the book, did you return it? Some of you? Yes. Well, they were like, we bought all these books, and now we're having to take them back. Well, sorry, I didn't know in time, and I'm not in charge of this course, so I did not know what they had for books. So, but none of y'all's fault. So we're going to talk about some of these topics here, and I'm kind of doing them all at the same time. Okay? Now, the textbook itself, actually, this is a link straight to Chapter 1. If you take this off, I think it goes to the actual book. Let's talk about, first of all, how this book works. This is a free book. openbookproject.net. It's a good source. They're free. They are updated by multiple authors normally, and they're kept current for the most part. But, you know, it's just like everything on the internet. Is it positively gospel? No. It's like Wikipedia. Should you always follow Wikipedia? No. But, I mean, a lot of the material up there is good. So it's not a bad deal. Today we're going to be covering the way of the program. Okay. Before we get into that, do you all know what a computer is? Yeah, we all know what a computer is. What is the computer? Is it this thing up here? What's this thing right here? That's a monitor. We have a monitor. We have a keyboard. We have speakers, we have a mouse, and we got that box on the floor. That's really the computer, okay? A lot of people call that the hard drive. I don't know, one of you might call it that. That's not the hard drive. Y'all know what the hard drive is?
It's inside of it. Right to memory.
Exactly. Let's take a look at hard drive. Hard drive is a component. Right there. These are hard drives. Hard drives is what's called non-volatile memory. When we save something, it's saved to this device. Now this device, for the most part, not always, for the most part is spinning. These normally spin somewhere between 5,400 and 7,200 RPM. Some even spin faster than that. And this little head, like you can see here, this head here, see if we can get the picture bigger, this goes back and forth. And it actually writes very, very quickly. Okay? But the computer has this inside of it. This is where we store stuff. We also have something called volatile memory, or RAM. This is the stuff that when we're actively working the computer, here's where it's at. We turn the computer on, it loads it in the RAM, or it loads it in the memory, so we can use it. What happens if I turn the computer off? It's pretty much gone. Okay? Now, over the years, they found out it actually is not always gone. Sometimes they found that you can actually freeze it move it from one machine, put it into another, and actually get the data off of it. Kind of scary. There's lots of different things they can do to it, but normally, for the most part, memory, if you turn the computer off without saving, it's gone. Okay? Our machines also have what's called temporary memory, or a page file, where sometimes it does write to that temporarily, so that's why in the forensics field, sometimes you can get data back even if it wasn't saved. It's like whenever you cruise the internet, obviously your searching and everything is stored. Do you all realize that every time you search for something in Google, they keep it forever? Every time you've ever searched for it, it has been stored somewhere. We had a guy, his name was Charles Thigpen. He was the Postal Inspector General of Oklahoma. He came and spoke to our cyber club, quite a few years ago now. And they were tracking down an anthrax attack against a bunch of banks. Well, I forget which branch it was, Arvist, or whatever branch it was. These people, or someone, sent a bunch of anthrax, turned out it was fake, but sent it to all these banks and said, here's your anthrax, you're going to die, basically. The way they found the guy was, they went to Google and said, hey, did anyone in the entire world search for all these bank names at the same time? Google said, matter of fact, there was. There was one computer in the University of Arizona that did. Who would have thought to even ask that question? So they went to Arizona, but it was inside a computer lab kind of like this, so they really couldn't figure out who it was at that point. But then they tracked the letters that went to the banks. They tracked them and found out where they were sent from. They were all sent from the same post office in Texas. So they said, okay, if they were sent from this post office in Texas, maybe someone flew there from Arizona. So then they checked the rental cars, because obviously if someone flew, they needed a rental car. Sure enough, someone flew in, and the miles on the car was about the same distance from the airport to the post office and back. It's amazing how they found this out. They caught the guy. They caught the actual person that did it. So, kind of funny stuff. But, yeah. So, searching, I know some of you are scared now. You mean that is actually saved? Yes, it is saved somewhere. Do y'all know what incognito mode is? Well, if you don't, I'm going to show you. Okay. I ran an ISP for years, Internet Service Provider. And I made web pages for people. And when you search a lot of stuff, it's kind of like if you search for, I don't know, what did I search for the other day? Darn it. I was searching for something. The next thing I know, my Facebook feed has all these advertisements for that item. Anyone ever noticed that before? You search for something like I was looking for something for my wife. The next thing I know, my Facebook is full of it. Yeah, and there's a guy, I can't think of his name now, darn it. The guy who makes these stupid spoof videos, but what they do is they track what you do. So Google's free. Do y'all agree with that? Facebook's free. Then why are they worth billions of dollars? Because they track everything you do. They sell it. But inside of Google, I can go over here and I can do new incognito window. What's happening is Google is still tracking my search. They're still keeping track of whatever I search for. But it's not stored on my computer. It's not in my profile here, and that's where Facebook gets it from. Facebook gets it from my search history on this computer. Okay? So if I was searching for cell phones, obviously it was stored in my cookies. It was stored everywhere on this computer, and then when I bring up Facebook, it would start showing me ads for cell phones. But with incognito mode, it doesn't save it. So I try to do that. When I'm searching for something for other people that really doesn't pertain to me, I try to do it in incognito mode, not to be sneaky, but that way it's not in my search history, and that way I don't see advertisements for cell phones or something that I'm not really interested in. Okay? So, we got a computer, and a computer is made up of hardware. We talked about the hard drive a little bit. Now, there's a bunch of new ones. I don't know if I mentioned this the other day. M2 drive, did I tell you guys about that? Actually, one of my students told me about it. there's something new called M.2 drives, M.2 drives, which is basically a hard drive that fits into like a PCMCIA slot. That's the hard drive. No moving parts. Very fast. Much faster than what we have now. I mean, I have a MacBook at home, and I also have a Surface. They have SSD, in other words, the hard drive in my MacBook does not spin. Okay, I'll show you what an SSD is. Okay, here's my, oh gosh, I don't want to do that. Okay, this is an SSD. Okay, so we have a normal hard drive here that spins, what, $13,000? What the heck? But this is an SSD, no moving parts. But, it's so much so. This here is an M.2 drive, and it's actually much quicker than this. So we're going to get to the point where our computers are just on. My Surface is basic. Anyone have a Surface in here? No one has a Surface? I bought one. I had Roach State buy me one. Because of all the darn students. Well, a lot of my students have one. And last semester I signed a project in forensics. And a large percentage of my students were complaining it wasn't working and they couldn't get it to work. Well, it turns out it doesn't work on a Surface. Because I had Rose State buy me one. That way I can at least test some of this stuff for some of the students. But I turned my Surface on, and within a few seconds it's up and running, even if it's totally turned off. My MacBook's the same way. Yours is probably the same way. I'm assuming these are newer. They look newer. Okay. Now this computer on the desk, not the fastest thing in the world, but they're decent. Okay. So, the computer has a hard drive. It has some memory. Has other components as well. We needed a floppy drive the other day. When's the last time you all saw a floppy drive? Long time. But floppy drives, there's all kinds of other ports. There's a lot of components in that box. A lot of people refer to as the hard drive. It's not really the hard drive. The hard drive is just the storage device inside the box. Okay? Then we got a lot of peripherals. This is all this other stuff. This keyboard, this mouse, this speakers, this monitor, this camera, this everything. Do I need all this stuff? Not necessarily. If I'm going to make a machine that literally just runs in a cabinet, I really don't need any of this stuff. I might need it when I'm configuring it, like a lot of stuff you do remotely. Like I can actually sit here, and let's pick a room. I wonder if someone's in that room. Let's go to BS-129. I can go to BS. Watch it pop up. Oh, I can't get in that one today. Okay, there you go. I'm actually connecting. I don't want to connect because it's actually going to log me off. But I can remotely connect into my office machine. Okay? I remotely connect to this machine every single day before class. I get in here and put all the files I need in it. So, there's this program called Remote Desktop. And there's also another program I use called TeamViewer. Anyone ever heard of TeamViewer? I connect to my home machine all the time with it. I connect to my home from work, and I connect to my work from home. It allows me to get in and remotely manage things. So, kind of cool. But yeah, remote access is a big deal with computers now because, and another way you can get into it is like this here. If I go to BS-104-01, I connect to I'll go to my C drive. There you go. I'm actually in my computer down in my office remotely. I can put files there, take them off, I can do whatever I want to do, and that's how I put stuff up here right before class. So, kind of handy to do, and sooner or later you guys will probably do stuff like that. So, okay, so we got our computer made up of hardware. Now we have software. Really, the computer doesn't do much on its own. You have to, install the operating system. What operating system are we running in this room? Does anybody know?
Windows 7.
Windows 7. Okay, they're running probably Sierra, I'm assuming. Yes, maybe OS something. Okay, anyone else run anything different? Does anyone run Linux in here?
Raspbian.
Okay, Raspbian. What do you run? Oh, Ubuntu. Okay. What was the first part? Arch. Never played with Arch. But how about a Raspberry Pi? Y'all seen a Raspberry Pi? I'm gonna show you what a Raspberry Pi is. Okay. Here's a Raspberry Pi. It's an entire working computer for about $35. Yeah, exactly. It even says there, $35. We have 20 of them downstairs. We did a summer camp for a bunch of high schoolers and teachers, and we hid those all over campus. We hid them. They had to find them. They had to get into them. They had to read the webpage and answer questions. They thought that was the coolest project in the world. Bill Richards, he teaches our Unix Linux class here. If you ever take that class, he'll teach you everything you ever want to know about it. We did a balloon project last year that we're going to do again this year. We took a helium weather balloon, launched it from Choctaw Creek Park, and tracked it all the way to Prague. Got up to 101,000 feet before it exploded. But we actually built the components that went in a styrofoam box. We had Raspberry Pis in it with some cameras. We took pictures of when it went up and when it down. It was the coolest project ever, all done by students. We're going to do it again this year. So if y'all are interested and you want to do something outside of class, maybe something to look into. I'll let you know more once we're going to actually happen. But see, an issue here at Rose State, y'all come to class and you leave. Then you come back for your next class and you leave. There's really no camaraderie. You don't do anything outside of class, and that's where you learn a lot of stuff. But so yeah, we're going to do that project again this year. But I mean, $35 for an entire working computer at home. If you know what a Roku is or an Apple TV, this can do all that. You can stream media from here. You can do pretty much anything. You can run security cameras off of here. You can do whatever. So it's kind of cool. So there's a lot of different peripherals we can use on here, okay? So I talked about remote access. So the software. Some of you are running Linux. Some of you are running Mac. We're running Windows here. I run a variety of them at home. And mainly the reason I do that is because of y'all. If I run just Windows and she comes up with her Mac, I'll be like, I've never seen that in my life. So that's why I try to be proficient. When I talked to Rose State into buying me one, I didn't want to use it because I'm used to Windows. So what I did was I went home and I basically took my Windows laptop off my desk, put it down, and said, okay, for the next 2 weeks, Macintosh only. And I'm pretty proficient at it. So it's one of those things that you have to play with it to the point where you get to. And Ubuntu, I mean, it's not hard. Once you get it up and running, it's pretty darn simple. But I bet way over half of you have never even seen it in your life, and you probably freak out. I was in an Australian airport. They got those internet terminals everywhere. They're all Ubuntu based. Just because I saw one of them kept rebooting, it was having issues, and it was Ubuntu. It's all free. So, okay. So, we got our operating system. That's what pretty much runs the computer itself. That's the Windows, the Mac, the Linux, the whatever you're running. Then on top of that, we have application software. Am I using any application software right now? I'm using Google Chrome. I also have PowerPoint up and running. I also have camera software. Those are different applications that run on top of my operating system. Now, those are different based on OS. Okay? They got a Mac over here. Google Chrome runs on a Mac. But does my camera software run on a Mac? Well, actually, there's a different version of it that does. It's not cross-platform. Python, on the other hand, you can make something for Python on Windows. Guess what? Runs fine on a Mac. Runs fine on Ubuntu. Runs fine on Raspberry even. I mean, it runs on everything. Java's the same way. You can make Java work on Windows, Mac, and that's what I like about it because I can go home and grade homework on my Mac or on my Surface or on my Rose State, whatever. You all know you have a Google Drive account, don't you? You know it's unlimited storage for life? I have 760 gigs in mine so far. I'm taking my entire movie collection from home, converting it to digital and putting it up there. Yeah, if you go in my office right now, there's a stack of movies on my desk. I'm just converting one by one, converting them to digital, putting them up there. Because it's so nice. Yes?
What are you going to do with the DVDs after?
Probably give them to you if you want them.
I would be so down.
I have hundreds of them. Okay, yeah. Okay, but I have tons. We did the same thing with all of my audio. I have iTunes Mats for iTunes. And yeah, all my audio is done that way. I'm just trying to get rid of all this stuff, you know? Catch Me If You Can. You ever seen that movie? I love that movie. I have 3 copies of it. Spider-Man 2, 3 copies of that. Die Hard. I got Die Hard. Then they came out with Die Hard 2. So my wife bought me the box set. Then they came out with Die Hard 3 and bought me the box set again. Die Hard 4, the box set again. So I have many copies of Die Hard 1. Many copies of Die Hard 2. Exactly. But the point is, you need to start using that kind of stuff, okay? And I can actually get into it right here without even knowing the password. Imagine that. Oh, I got to tell it to sign in with, hold on, this is a different one. That's this account, but it's going to be the wrong password. Then we need to select this password and allow it. So I've never logged in. Okay, fine. Whatever. Go away. Now if I go down here and I go, this is the wrong one. Darn it. I got too many accounts. I need you to get into the other one. Oh, I've never signed in from this computer. But trust me, I got tons of movies up there. 7 or something gigs at this point. But you guys need to start utilizing that. Cloud storage is amazing. Dropbox, y'all ever use Dropbox? Dropbox is good. I used them for many years until last semester. I started putting all my software from my classes up there because you as students would need access to certain software, so I'd share it with you. Dropbox says, nope, too many people accessing it, your account's been blocked. Like, what the heck? So OneDrive does the same thing, so that's why I switched everything over to Google Drive. Okay. So back to what we were over here. We have hardware and we have software. Software is also games. In other words, a waste of time. But it is also games as well. Okay? Back a little bit about hardware. We have some things that give us input. A mouse would provide input. You okay with that? A camera could provide input. Now this camera has a microphone and a camera on it. Some do multiple things. Okay, this is just a microphone alone. Okay, then we have output devices. We have a screen here that's an output. But now on my Surface, my screen is output and input. This is a touch screen. Okay. We also have processing. That will be our CPU, our central processing unit. Let me show you what a CPU is. Show you a lot of pictures here. Okay. This is a CPU. Okay. Moore's law states that every 18 months, the number of transistors on our chips double. So in other words, our computers get twice as fast every 18 months. And if I could show you, last year's Apple keynote, they showed the new MacBook. Well, what was cool about that, I still remember that one. They showed the prior MacBook. Then they showed the new MacBook. On the inside, the components on the inside had dropped half size. Literally half the size. And they're like, so what are we going to do with all this extra space? Put more batteries in it so it can last longer. Points were getting smaller and faster and quicker. So, do any of you keep really old computers around forever? I have old. Why?
Why not?
Well, that's a good question. Why not? But a really good friend of mine, literally the only friend I still have when I was in the Air Force, I was over his house the other day, and he's like, yeah, I got this 2-year-old computer. I don't use it anymore. It's old. He's like, what are we going to do with that? I said, just give it away. Why keep that stuff forever? I'm trying to go through my house and get rid of junk, hence my DVDs. Okay? Trying to get rid of stuff. But a CPU is it handles the processing. That's what does the math. It does all the calculations. It's one of the components that make our computers fast. The other component is that memory. Okay? That memory I was telling you about. This right here. The more memory, the better. Okay? Think of memory. Okay, we all have our cell phones, obviously. Now, if you're going to call someone, do you know their number? No, because we don't need that anymore because it's all in our contacts. Well, this is the thing that holds our phone numbers for us. The more phone numbers it can hold, the faster we can call people and do stuff, okay? You ever get a really small cell phone and run out of space? Yeah, I did that. My wife, I got 128 gig and it's like a quarter full. My wife has 128 gigs. She keeps running out of space. I'm like, seriously? How? How is that even possible? Well, My stepdaughter used to be in band. She had to film everything. Everything at all times. I was like, seriously. But the more memory, the better. That's what really makes your computer faster. Faster CPU and memory working together. Really, the hard drive, the storage, that's going to have a small amount to do with the speed of your computer. Okay, so we got processing. We talked about storage already. We have RAM. That's that stuff right there that we use while we're using the computer. Okay. Now, I talked about application software already. That would be our Python. That would be our Chrome, stuff like that. Our system software could be the Windows or the Mac. Okay. Now, let's talk about some logic for a second. Okay. Here's some simple logic. The reason I'm not doing it in regular presentation mode is so I can keep switching back and forth. So let's look at this recipe. Get a bowl, stir, add, what's that say, T7's whatevers, okay? Add 2 eggs, 7 pounds of flour, bake at 350 degrees for 45 minutes and eat. Okay. Again, Jeff wrote this. Note, this is a horrible program. So what do you think? Is that a decent program? Is that logic correct?
No.
It is and it's not. Okay? So let's start looking at the top. Get a bowl. Okay? What are the odds that we all get the same kind of bowl? Some of you might get a cereal bowl. Some of you might get the big Mondo bowl. I mean, what size bowl are we talking here? Are we cooking for a family of 4? Are we cooking for the entire, state of Oklahoma?
Okay. Stir what?
Yeah, exactly. Stir what? We haven't put anything in it yet. So we got a bowl, and we're stirring it here. Okay? Now we're going to add a bunch of somethings to it. Okay? It's kind of important that you know the quantity of measure. In this case, it could be tablespoons or whatever he put here. So it's kind of precise. And when working with software, do you think it's important to be precise? Yes. Crazy important. I had a student this morning, I was grading his program. He had to write logic like this for a program that tracked expenditures. Okay? So he said, input expenditure. Okay, actually I'm going to write down exactly what he had so you can see it. Okay, what? Notepad's not on there? There's Notepad. Okay, let me make my font crazy big since y'all sat in the back. I like Lucidia. Let's go down here to 24 or 26. Okay, input, expend. Okay, so what would that mean? What do you think that might mean, anybody? Right, get input for a number. How much money you spent, okay? Well, one thing is missing is we didn't tell them what to input. We didn't, see, normally when you write a program, can you imagine if you go to a website and it's got a box? That's what we got right here. We don't have a clue what we're supposed to put in the box, okay? So you might want to say something like print, please, spell it right, please. Please enter. So now we're asking, hey, please enter your expenditures. And then we're going to get input for expenditures. Does that make a little more sense now? Because he just had the input. I'm like, okay, you're going to input expenditures, but did you tell the person that you're going to get expenditures? Because the user has to know what's going on. Little, if it was just a web page with a box, you'd be like, I don't have a clue what this means. Okay? Then he went down there, and here's the part I really had an issue with. It said, if EXP is greater than 75%. So if the expenditures is greater than 75%, he's supposed to do something, okay? But do we see a problem between those two lines, the input and the if statement? Well, I mean, not that there's a blank line. But when you're working with computers, so we got input for expenditures. But then we're checking if EXP. They're two different things. We as humans realize that EXP is just short for expenditures. But do you think the computer's automatically going to know that? No, it's not going to have a clue. It's going to be like, okay, I got expenditures, I got EXP, okay, two different things. Now what are you supposed to do? Well, what'll happen if you're going to run this program, you get input, but then EXP is going to be 0 or no or not defined or something. And then it's going to error out or give you erroneous input. Or, it's not going to work correctly. Okay, so that's why I told him you got input for expenditures, but then you're checking if EXP is something. Okay, it's not a good thing. Okay, what if here a lot of students do this too? They'll do this: input for expenditures with capital E, then they're checking with a small e. Depending on your language, that can be an issue. Java, big issue. Visual Basic could care less. Visual Basic, you can spell it any way you want. It's like, wow. Okay, so we got our program over here. So we're getting something. We're going to add 2 eggs. Well, it didn't say what size. Does that matter?
Yes, large eggs.
Should be large. Now, when we go to the store and buy eggs, we get large eggs, because that's all they sell. But my father-in-law has about 100 chickens. Well, a whole bunch of the babies are now laying eggs. You think they immediately lay large eggs? No, they're small. So if you're going to use some of these smaller eggs, it's not going to be the same. So that's why the recipe should say, add 2 large eggs or extra large eggs. Anyone ever see a triple yolk egg or double yolk egg? I used to work at a chicken farm, and there's some crazy stuff in there. And it was funny because I went and got the eggs last weekend. I went over to their farm. And they had 4 chickens that are basically sitting there trying to hatch the eggs. Well, Connie, his wife, was going to let him hatch the eggs. But he didn't want him to. And she wasn't home, so I asked him. He goes, no, don't let him sit there. Just take them out. So I took them out. And she comes, she's like, you took the eggs out. I'm like, yeah, Gary told me to. The problem is there's so many chickens that when they lay the eggs and they're free-range chickens, they go anywhere they want, the babies are getting killed. The roosters were killing them. They were just dying. So we don't want them to hatch their own eggs. But if a chicken was sitting on an egg, and then you take it out a couple days later, what could have happened? It could be growing. You all agree? So how do you check it? Put up to a light, flashlight. She had never heard of that. I'm like, seriously? So I took a nice bright light, put my hand out, put the egg on top, and she thought I was just giving her a hard time because she had mixed all the eggs up. I'm like, great, which eggs were they? So we're going through dozen after dozen after dozen. She's like, this ain't gonna work. Found one. Sure enough, a big old red dot in it, which means it was starting to grow. Okay, but the point is, 2 eggs is not precise enough. Okay. How about 7 pounds flour? Add 7 pounds flour. Is that good? You could say what kind. But can you even buy unsifted flour now? Isn't all flour now sifted? Back when I was young, you bought the flour, then you got that stupid sifter thing out, and you sifted it. Now isn't all, I guess you could say wheat or white or, but yeah, I think 7 pounds flour, okay? Bake at 350 degrees for 45 minutes. That's probably fine. But, yeah, but where are we living? Boy, that's Celsius. It's going to be a little bit different. But really, you kind of got to look at your audience, but now everything's becoming global. Come on, yeah, some of those instructions, when you open stuff up, you can tell they're written in Chinese, and they're like, huh? They need it, okay? So I guess we're going to be eating some very hot something, because we didn't even let it cool. We didn't serve it, we're just eating it. So it's not the best logic, but at least we can get an idea of what's happening, okay? We're going to talk about some errors, and we're going to go to the book and talk about some errors. You're going to get a lot of errors. We all get errors, okay? Syntax errors means something's not understood by the system. You told it to do something, but it doesn't have a clue what you're talking about. We don't even know what that task is. Add the whatevers of whatevers. It's like, what is this? I don't even know what this is, okay? So syntax errors, most likely you misspelled something. I have a really hard time because I used to teach Visual Basic and C++ here at Rose State in this room. And I used to teach them back to back. And it was funny one day. I taught the first class. I'm teaching the I'm nearly at the end of the second class. Someone's like, this is a C++ class. I'm like, seriously, I've been talking for a full hour now, and no one reminded me that I'm teaching it in the wrong language. Yeah, that was pretty bad. But syntax varies between languages. Okay? Some things work across, but not all. Now, a semantic error, maybe you didn't do it right. Okay, we're going to see some examples of that here in a second, but it's not an error. In other words, the program ran, it did something, but it's not quite what you wanted it to do. Okay? The output's not correct. Okay? So even if we correct the add 3 tablespoons of salt, this recipe would not make anything we don't want to eat. Yeah, obviously it's a bogus recipe. Okay, now let's look at the actual chapter. We don't need this window anymore. Let's go to this window. Okay. Okay. Why? Again, I'm keep going back and forth on this, but why are we writing programs anyway? Basically, to solve problems, to do stuff for us. Y'all, some of you know Roy, beard guy, long hair. Now has short hair, he cut it. But Roy works in room 208 here. He does a lot of stuff in the cyber program with me. Roy is a prime example of someone who writes a program for everything. If he has to do something, he tries to write a program for it, so if he has to do it a second time, it's done. I got hired years ago by the Oklahoma Insurance Commission to configure a virtual private network between Oklahoma City and Edmond, then Oklahoma City and Dallas. Okay? I charged them $600 for Oklahoma City to Edmond. Okay? Took me a few days. I had to configure these routers and get it all set up. So it took me a few days to do it, and I wrote a program to do it while I was doing it. So once I was done, it worked perfectly, and they were happy. But they're like, $600? That's a lot of money. And you didn't take all that long. So I said, not a problem. They said, we're going to do the second one ourselves. So I said, no problem. So they went to do the second ones themselves. So they were working on the one from Oklahoma City to Dallas. Okay? A few days later, they called me, and they're like, we can't figure it out. Can you do it for us? I'm like, sure. And they're like, how much are you going to charge us? I said, $600. I mean, so, like, okay, fine. So just to make my point, I went into their system. I wrote the program to do it already. I changed the name Edmond to Dallas, hit submit. Done. $600. And they're like, seriously? It literally took me 15 minutes. And they were not happy. But the point is, I wrote the program. They wanted access to my program. I literally just had to change Edmond to Dallas, and I was done. So we write programs to solve problems. Okay? That's what we mainly do it for. Okay? Python. Python is called a high-level language. Okay? Very easy to understand. Oh my God, easy to understand. It's probably the easiest one I've ever seen. There's other ones out there. C++, PHP, Pascal, C#, Java. There's a slew of them. Okay? Usage, first of all. I mean, you make a language for a specific use. Yeah, I used to work on a language called RMX, which is a real-time operating system language. It was made specifically to solve a certain task. Okay? It's like Fortran. Fortran is a scientific language. It was made. There's a movie called Hidden Figures. Anyone seen that? Excellent movie, Hidden Figures. That was Fortran back then. It was made just to do that job. Okay? Python was literally made by a guy over winter break. He was bored. I forget his name. I have it in another set of slides, but he was bored, so over winter break he made Python. I mean, it's crazy. There's just lots of them. C#, what they did was they took the good parts out of C++, the good parts out of Java, the good parts out of Visual Basic, and stuck them all together. So it works really good. Now, Python, we don't compile it. We write our program and we run it. It's interpreted. It's not compiled. Okay? Which we're going to see the difference in a little bit. But Python's just so easy to use. It doesn't require a lot of stuff. And it's also cross-platform. At least in the security field, we got some Windows machines, we got some Macintosh machines, we got some Linux machines. Wouldn't it be nice if the language works amongst all of them? Visual Basic, Windows only. C++, pretty much Windows only, even though there are some Linux versions of that. C#, Windows only. You know, a lot of them are particular. Now we got low-level languages. Low-level languages are like assembly language. Okay? I teach a reverse engineering class that we learn how to use assembly language. If you take a program that's written and decompile it, in other words, undo it, it ends up in assembly language. And I teach a class on how to do that, and how to break passwords, and how to bypass security, and all this other stuff. Well, that's a low-level language. And I can show you an example of assembly code, hopefully. Just give me an example of assembly code. There you go. Here's a perfect example of assembly code. We're going to push EBP onto the stack. Then we're going to move ESP into EBP. Then we're going to move if the 0 flag is set. And so we're going to load an effective address here. We're going to add. We're going to do a shift left. Basically, this is what's called a low-level language. Much harder to understand. Y'all agree that's much harder to understand? Crazy harder to understand. But when I take a program that someone wrote in whatever language they wrote it in, if I try to undo what they did, it's hard to get it back to the way they originally wrote it. Okay, I saw a show once of a guy who writes instructions for furniture. You know when you go to Lowe's, Best Buy, Walmart and buy that shelving unit, and you got those instructions that really suck? Well, did you know when they make those, they build it and give it to a guy? Here's the completed unit. Now write the instructions on how to do it. So he has to figure out how to take it apart and how to put it all back together. That's why the instructions suck half the time. Because it's not the person who designed the shelving unit who's writing these instructions. Well, when you decompile something, we get into something like this because we don't know what they originally wrote. So that's what's called a low-level language. A lot harder to understand, but wow, is it powerful. You can do everything in it. Okay? They mentioned how Python's portable. We can take it anywhere. Not a problem. Python uses, like they say here, an interpreter. That's that idle program. Okay? That's idle. Okay? This is what's... Actually, let's bring up idle. Everybody bring up idle. If I click on this, then I can click on all programs, and I can go down here, and I can find Python, and I can click on idle. You know, there's an easier way. You can really just click that and type idle, and it comes right up. Y'all know that? You don't have to click all programs, Python. You can just literally click the Windows key, start typing idle, and it's right there, done. Comes right up. Hopefully. There it is. Okay. This is what's called an interpreter. Okay. It interprets our commands. We're not going to compile it. We're not going to execute. We're just going to run it, and it's going to interpret what we tell it to do. Okay, we're going to play with that more in a second. Okay. Actually, let's do what they show here. Inside here, if I say 2 plus 2, we all know that. It should be 4. If I hit enter, sure enough, it's 4. Easy enough? Did everybody get that to work? So, what if I did 2 times 2? What should I get? 4 as well. Okay. So, whatever I'm telling you to do, it should do. Now, if we get really confusing, maybe, 256, whatever, a big old number times another number divided by another number, you'll see it interprets our commands and does it for us. Okay? So we have our prompt, then we get our output, like it says here. You type here, the interpreter responds with the results of that. Okay, the Python prompt is those little greater than symbols. Okay, got that already. We can also write scripts. There's a program they talk about here, Python Scripter, which we're not going to use. But you can there's lots of them. There's PyCharm, there's a PS script, there's tons of programs out there. I asked, did you guys use idle? Anyone know why?
Why?
Because it comes with Python. If I ask you to use PyCharm or something else, well, then now you're going to have to install Python. Then you're going to have to install PyCharm. If you don't install Python, PyCharm is not free. It is, but it's not. There's components of it that are free, components that aren't. And if you just use it, it's fine. Okay? And we're going to play with some script as well later on. Okay? Now let's talk about what a program is. First of all, does a program have to get input? No. We told it right here, 2 plus 2. 2 plus 2. No input. It just does something. But normally a program gets input, and it might do some calculations, and it produces output. It could perform some basic math stuff. Okay? It could do certain things based on a condition, kind of like I showed you in this notepad here, if EXP is greater than 75%. So we could have a program use a condition. Did y'all use a condition today coming to class? You should have. You should have said, if it's Wednesday, if it's time to leave the house, all that kind of stuff. You probably do that so often you don't even realize it. I'm sitting here, it's 1:20. Is class over yet? So if it's less than 1:45, keep talking. That's a condition. If it's less than 12:30, don't start talking yet. That kind of stuff. Okay? I was commenting to a student yesterday because he wrote an if statement, and he also wrote a looping statement. He basically was saying that, if there's food left, keep eating. And I'm like, wow, that could be scary. Depending on how much food you got, you could be a big person at the end here. He's like, well, luckily I got a metabolism that's very fast. So he goes, I could probably set it to say if 1 equals 1. So he said, or while 1 equals 1. So what would while 1 equals 1? Any idea? Okay, while is what's called the loop. We're going to talk more about loops. But 1 equals 1 is always true. Do you agree with that? Is 1 always 1? So we're saying here, while 1 is equal to 1, in other words, forever, continue eating. And I'm like, that's not a good plan, dude. I joined the Air Force. I weighed 114 pounds. My metabolism was very fast. Then someone put the brakes on it. It's bad. Bad news. So I was telling him, I said, that's probably not a good plan for you there. Okay. So we get input. We have output. That's where we could output to the screen. Is everything always output to a screen? No. More often than not, it's not output to the screen. Most of the time you're doing something, you're going to go on a web page and you're going to register for something, whatever you're registering for. Where's the output go? Probably some database somewhere or some system on the other end that's tracking whatever you're registering. Or Google's probably capturing this so they could give you ads about something. Okay? Math. We could do basic math calculations. We could do add, subtract, multiply, divide, modulus, all kinds of other stuff we're going to learn about. So I talked about conditional library. We could talk to a whole bunch more about that. And repetition. It's kind of like that while loop. Okay? Repetition is very important, but repetition is one thing that you really mess up. If you don't write your loops correctly, if you wrote a loop in there with while 1 equals 1, that program will go on forever. Okay? Tom Hanks movie, Apollo 13. Don't remember that one? If you don't watch movies, you're in the wrong class. That's where there was a problem with the space shuttle or whatever, and they had to figure out how to start it up correctly. And I mean, it's tough sometimes to get these programs to work right, and it's just amazing. They say that our microwaves have more power than an entire space shuttle did back then. So, crazy stuff. So repetition is something very important. We go to Walmart, or you came to class today. Where did you park? You probably drove around continuously until you found a spot. Now, you could have driven right into the first spot, then you really didn't repeat very much at all. But is there anybody here that keeps driving around until you get something on the front row? You ever seen those people at Walmart? No, I'll park way out there. It's not that far. You're going to walk farther in the store anyway. But there's some people that literally go up and down every aisle until they get to the front. So, repetition is to repeat some action repeatably, usually with some variation. I'm going to continue until I find a parking spot, or until I'm full, or until it stops raining. It's like, I guess, it rained last night. I guess it rained around here, what was it 6 or 7 o'clock that started raining here?
It was about 6:30.
Okay. Because our secretary actually worked late last night. Wow, first time in history. Because it was raining so hard, she didn't have her umbrella, and she didn't want to, I guess, die. I don't know. But she was saying, yeah, she was here until 6:30. So she was probably, 7:30. She was probably repeating is it still raining out there, until it stopped raining. Okay? So believe it or not, this is pretty much all there is to it. Programs are really very simple. But, we're going to see how that's a little tougher. Okay. When writing programs, we use something called an algorithm. An algorithm is the logic behind it. We come up with, this might be a little vague, but when it comes back to the topic later, we'll talk about algorithms. Okay? And that's the thought process behind it. Do you think you're ever going to write a program perfect the first time? We're going to write actually, let's write this program. I want you to say the word hello on the screen. I know you've probably seen the examples. If I type print in parentheses and hello, I need to change my font. How did I do that in this one? Font. Let's go. Where's my Lucidia? Lucidia Sans. Let's go to huge. That sure didn't help a lot. Oh, wait. Oh, that was the indenting. My bad. Sorry. Font's over here. Oh, yeah. Okay, so if I type print hello, okay, and hit enter, it says hello. Okay? So what my program did was I told it to print what's called a method or a function, depending on which language you're referring to. I told it to print something. Did I tell it where to print it? No, so it's going to default to the string. I told it to print hello. Hello's green. Y'all see that? That's because it's a string. It's a string of characters. String of characters in Python need to be enclosed in a double quote, or and also if I bring that up there, let me show you what I just did. I can't edit this line. But if I go to the line and hit enter, it brings it down here. Then now I can edit it. Okay? So it's either going to be closed in double brackets or single. Seems like it does the same thing, doesn't it? For the most part it does, but not totally, and we'll talk more about that later as well. Okay? Now, what would happen if I did a single quote at the beginning and a double quote at the end? Think it'll like it? It's like, whoa! End of line while scanning for a string literal. Basically, now we're doing what's called debugging. We're running our code and trying to see if it works. Okay? There's obviously an error. Okay? Debugging is very important. Now, I get so many people that write their entire program then hit run. Is that a good plan? That's kind of like building the entire house and then checking to see if it works. Yes, sir.
You said we're not going to compile or anything, we're just going to write it. So when we actually make a program, are we going to actually run it?
Yes, we are. We're going to run it. We're going to basically interpret it. We're running. Yes. We're just not going to compile it. Python does it line by line by line by line. It can take branches and stuff. But, yes, we will be running all of them. Okay? And let's actually, you know what? I'm going to answer that question right now. I'm going to go over here and I'm going to click on New File. Follow along. Click on New File. And I'm going to call this one, actually I'm going to type that same command in there. Print hello. I'm going to save it. So I typed in print hello. Everybody got that? I'm going to save it. What should I save it as, anybody? Hello would probably be good. So I'm going to call it hello.py because it's a Python script. Now, in Java, the name is very important. Not so much in Python. Okay? So those of you who know other languages, you'd be like, what? Seriously? Okay. So now I'm going to save this hello.python. Done. Now in here I can actually run it. I can click on run. And right there, see run module? Look what it got. Look at my font's huge. But it restarted my shell. It restarted my Python shell. And it ran the script. That's my path. It ran this script and output hello on the screen. Everybody see that? So we ran it. Okay? It did the same exact thing. But the only difference is when we entered it up here, we weren't saving it anywhere. Okay? So now we can take this script over here and we can say hello, Bob. And I can hit F5. The reason I know F5 because if I clicked on run, it said F5. So I can hit F5 and it's like, whoa, do you want to save this first? Most definitely. Now it says hello, Bob. You guys have homework assignment in this. It's due at 1:50 today, by the way. What I want you to do is I want you to write this hello program, but it must say hello and your first name backwards. So if my name is Ken, it's going to be N-E-K. That way, if you weren't in class, you wouldn't know that little tidbit of information there. But I know you're in class. So now I'm going to run this again. It should say hello, N-E-K. And sure enough, it says hello, N-E-K. Everybody got that to work? Very simple, isn't it? I could have done that in my interpreter at the Python prompt right here. I could have said print. Now, when I type stuff, I like to put in both my parentheses right away. Let me bring this up so y'all can see it. I don't want this one. Trying to make this up a little. Okay. Well, I like to put in both my parentheses. That way I know I have a match set. Okay. For instance, like when I do hello, if I put both of those, then I know I have the correct number of parentheses. I know I have the correct, quotation marks. I know I have everything. So when I do that, again, I'm interpreting it, but again, this isn't in my script. This is inside the interpreter. Okay? You could do the same thing at the command prompt or at your terminal window and all that. Okay? But for the in-class exercise today, submit that. Make a program. I called this one hello.py. I don't care what you call it. Just call it hello. It's fine. Make it say hello, your first name backwards. Then upload that to the Dropbox. The Dropbox is good until 1:50. So you don't have to do it yet, but do it before you leave today. Okay? Now let's go back to where we were at. Okay. Good question. Thanks for bringing that up, though. Okay. So debugging is when we screw up. Or when we fix our screw-ups. So maybe, again, I put that single quote in here. It looks correct. It's green. It looks perfect. I hit F5. Whoa, something wrong with it. End of line while scanning string literal. What that really means is, okay, right here, we got a string. We know it's a string because I got a double quote. Where's the end of it? There isn't one. So that's why it gave me that error. Okay? Make this so it's not so huge either. Okay, yeah, but debugging is finding errors, finding bugs in our program. Okay? We talked about syntax errors. Let's talk a little more about them. What if I fix that error, but I spelt print wrong? Okay? I spelt print wrong. Go to run it, it's like name print is not defined. Why didn't it tell me I spelled print wrong? Anybody? It didn't tell me I spelled print wrong. It says name print is not defined. Well, maybe I'm making a variable called something else. It's not totally sure. It's just definitely not print. So that is what's called a syntax error. Hey, the reserved word or the keyword print is wrong. So I'm going to fix it. Fix it, hit F5, boom, we're done. Okay? That's a syntax error. We also have runtime errors. Runtime is maybe I'm going to open up a floppy disk. I'm going to open up a file, and it goes to open the file, and the file doesn't exist. It's something that syntactically is correct. The spelling's right. It's got the right number of parentheses. It looks good, but something when it ran didn't work out so well. Okay? And then semantic errors. Okay. Now let's make a semantic error. Okay. Now I'm going to print out 2 plus 2 times 6. Okay? I want the number 24 to print. Okay? 2 plus 2 is 4. Times 6 is 24. Do you all agree? I want 24 to print. Okay? I know that's not right. But that's what I want to happen. Logically in my brain, I want the number 24 to print. 2 plus 2 is 4. Times 6 is 24. So I'm going to run this. I got 14. So that's what's called a semantic error. There's nothing wrong with my code. My code's absolutely perfect. The computer's doing exactly what I told it. It's just that I don't know what I'm telling it. Okay? Why did it do that? Someone in here knows.
It times the 6 times the 2 and plus.
It, order of operations, it timed the 6 first. How can I fix that? I can put some parentheses around the 2 plus 4. And do that. Will that fix it? So is it correct now? No? We got to know. Okay, that's not going to work then. What else could we do?
Single brackets, maybe?
Single mean these. That'll make it into a character. That won't work. So, because, yeah, I want 24, but I'm only getting, wait, what am I getting?
Don't you parentheses the 2 plus 2?
There. Well, okay, hold on. Let's try that. Hold on. Let's do the 2 plus 2. Okay, no, I did get 24. Okay, what was I saying a minute ago? Do I want 24 or I want 40? I wanted 24. Okay, sorry. So this is right then. What this caused it to do was add 2 plus 2. Sorry, I forgot what I was trying to do. I added 2 plus 2 and I got 4. Then I did 4 times 16. Without the parentheses, order of operations told it multiplication before addition. Then, so multiplication before division. So what it did is it did these two first. 6 times 2 is 12, then added 2. Okay? Yes, sir.
Okay, this is about the homework. Do you want us to upload like the saved file or a screenshot?
I want the saved file. I want the hello.py. You know what? That's a good question. I'm glad you brought that up, even though you don't know what you brought up. All right, I'm going to show you something here. Here's the way your Windows is most likely configured. And if it's... Does everybody's look like that with no extension showing? Yes? If yours looks like that, that's hard. Your Mac's different. Okay. Your Mac shows it correctly. In Windows, by default, Windows hides file extensions of known file types. So, because this is called hello. But if I want to call it hello.py, what should I do? Rename it? Put hello.py. Make sense?
Won't that make it .py?
It's going to be .py.py. because if I go under organized folder search options and view, there's a stupid checkbox here of hide file extensions and known file types. The worst thing in the world. Causes so many viruses. So I turned that off. Now it's hello.py.py. Because by default, it hides that stuff. Okay? So just, and if you mess it up on the first time, I'll know, and I'll help you fix that. But I want you to save it as hello.py, and it's going to be the whole print the name with your first name in it. Again, it's going to be this one here. Save that, and then upload it. Okay? The reason is your programs are going to get longer, and screenshot ain't going to work. You're not going to be able to get the whole thing. Actually, I guess you could with smaller font. And I run your programs. It drives students crazy. I'm like, you don't want a screenshot? I'm like, why? I'm going to run it myself. Why do I need a screenshot? Because if you wrote it correctly and you got it to work, I should be able to get it to work, don't you think? Now, if I get it to work and or if you got it to work and I didn't, that means either you submitted somebody else's program or you screwed something up or something. Yes, sir.
Hey, I got a question. Like in the Mac, whenever I press F5, it just brings up a box with questions.
Oh, don't hit F5 on a Mac. Okay. Click on Run. What is the command on Mac to run it?
It says F5.
Is it F5? Oh, turn on your function key then. You should have a function key down there at the bottom.
Yeah.
See if that does it. What now?
Oh, you have to hold down F and then press F5.
Okay. It's something a little bit different. I don't remember exactly what it is on a Mac. And you can always just click Run as well. It's just, Okay, so let's continue on. We got 5 minutes left. We're not going to finish. Okay. So do you understand the different, you know what a semantic error is? That's when I messed up and didn't have the math in the right order. Could I have fixed that without parentheses? Remember, I want 24, and I got this. Could I have fixed that without parentheses?
Could you set a variable equal to 2 plus 2 and multiply by 6?
Yeah, but I don't know about variables yet. I could just reorder the math. Okay? No. What are we trying to do again? We want 24, correct?
24.
No, there's no way to do it then.
Yeah.
Oh, heck. There is no way to do it without variables or parentheses or something. No, there isn't. No. Without changing the numbers. No. I could do 6 times 4, but that's cheating. Oh, well. Forget that. That error didn't work. So semantic is a logic error. And what sucks a lot of times is you don't realize it's a logic error until it's too late. Okay? All right. So syntax errors, we talked about those. We typed a letter wrong. We typed print wrong. We typed it as pernt. Runtime error, those are much harder to detect when you're looking at it, but obviously easy to detect when you run it because it crashes or something. The semantic errors, I've talked about that one as well. Experimental debugging. When you debug a program, you should try everything. Okay? Just because it's asking for letters, you should put in numbers. Just because it asks for 4 characters, try putting in 12 characters. Why would you do that? Have one idea?
That's why you might mess up and put the wrong thing in.
Exactly. Someone might mess up, put in the wrong stuff. I was filling out a form on AAA's website yesterday, and I don't know why, but I couldn't see the boxes. I don't know. It was weird. It was just, they were there. I had to just click around until it highlighted them. But, I mean, you never know what people are going to enter. So try it with everything. Now, for this class, you're going to be fine. I mean, if you tell me to enter a number, I'm going to enter a number. But in the real world, you need to try other stuff. Because if you ask for a number and they enter a letter, what do you think happens? It potentially could crash. Or it could give you the ASCII value of the letter, which we'll talk more about later as well. Okay? Formal languages and non-formal languages, or natural languages. It says natural languages are languages that people speak. That's our English, our Spanish, our French. Okay? Formal languages are what we're learning here. Okay? Okay, notations, mathematicians. again, we're not really writing anything really difficult yet, but computer programs are there to do this specialty math and this specialty whatever, okay? They talk about something called tokens. When I wrote this code right here, when I said print hello NEK, there's a couple tokens in there. First of all, there's print. Print is the method. Then we have a parenthesis. Then we have a double quote. And then we got a series of characters. And then we got another double quote. And then we got another parenthesis. All those are different tokens. And when I went to University of Tulsa, I actually had to write a program that would capture all these tokens and figure out what they all do. And it gets a lot more complicated than you could possibly believe. Okay? Are we going to be able to finish this? No, we're not going to be able to finish. We're out of time. Okay. We're going to finish up this chapter next time. But for this in-class homework, you got 5 minutes. Submit to your hello.py program. Okay? Then you're out of here. If you don't submit it by 1:50, you missed it.